So the first example I'm going to talk about relates to children with learning impairments, and we now have a large body of literature that demonstrates that the fundamental problem that occurs in the majority of children that have early language impairments and that are going to struggle to learn to read is that their language processor is created in a defective form. And the reason that it arises in a defective form is because early in the baby's brain's life, the machine process is noisy. It's that simple. It's a signal-to-noise problem. Okay? And there are a lot of things that contribute to that. There are numerous inherited faults that can make the machine process noisier. I might say the noise problem can also occur on the basis of information provided in the world from the ears. If those of you who are older in the audience know that when I was a child, we understood that a child born with a cleft palate was born with what we called mental retardation. We knew that they were going to be slow cognitively. We knew they were going to struggle to learn to develop normal language abilities. And we knew that they were going to struggle to learn to read. Most of them would be intellectual and academic failures. That's disappeared. That no longer applies. That inherited weakness, that inherited condition has evaporated. We don't hear about that anymore. Where did it go? Well, it was understood by a Dutch surgeon about 35 years ago that if you simply fix the problem early enough, when the brain is still in this initial plastic period, so it can set up its machinery adequately in this initial setup time in a critical period, none of that happens. And what are you doing by operating on the cleft palate to correct it? You're basically opening up the tubes that drain fluid from the middle ears, which have had them reliably full. Every sound the child hears uncorrected is muffled. It's degraded. The child's native language in such a case is not English. It's not Japanese. It's muffled English. It's degraded Japanese. It's crap. And the brain specializes for it. It creates a representation of language crap. And then the child is stuck with it. Now, the crap doesn't just happen in the ear. It can also happen in the brain. The brain itself can be noisy. It's commonly noisy. There are many inherited faults that can make it noisier. And the native language for a child with such a brain is degraded. It's not English. It's noisy English. And that results in defective representations of sounds, of words, not normal, a different strategy, by a machine that has different time constants, different space constants. And you can look in the brain of such a child and record those time constants. They're about an order of magnitude longer, about 11 times longer in duration on the average than in a normal child. Space constants are about 3 times greater. Such a child will have memory and cognitive deficits in this domain. Of course they will. Because as a receiver of language, they're receiving it and representing it in an information that's representing crap. And they're going to have poor reading skills because reading is dependent upon the translation of word sounds into this orthographic or visual representation of form. If you don't have a brain representation of word sounds, that translation makes no sense. And you're going to have corresponding abnormal neurology, and then these children increasingly, in evaluation after evaluation, in their operations in language and their operations in reading, we document that abnormal neurology. The point is that you can train the brain out of this. And the way to think about it is you can actually refine the processing capacity of the machinery by changing it. Changing it in detail. It takes about 30 hours on the average. And we've accomplished that in about 430,000 kids to date. And actually, probably about 15,000 children are being trained as we speak. And actually, when you look at the impacts are substantial. So here we're looking at the normal distribution. And what we're most interested in is these kids on the left side of the distribution. This is from about 3,000 children. And you can see that most of the children on the left side of the distribution are moving into the middle or the right. This is in a broad assessment of their language abilities. This is like an IQ test for language. The impact in the distribution, if you trained every child in the United States, would be to shift the whole distribution to the right and narrow the distribution. And this is a substantially large impact. Think of a classroom with children in the language arts. Think of the children on the slow side of the class. We have the potential to move most of those children to the middle or to the right side. In addition to accurate language training, it also fixes memory and cognition, speech fluency and speech production, and an important language-dependent skill is enabled by this training, that is to say reading. And to a large extent, it fixes the brain. So you can look down in the brain of a child in a variety of tasks, as scientists have at Stanford and MIT and UCSF and UCLA and a number of other institutions in children operating in various language behaviors or in various reading behaviors. And you see, for the most extent, for most children, their neuronal responses, complexly abnormal before you start, are normalized by the training. Now, you can also take the same approach to address problems in aging, where, again, the machinery is deteriorating. Now, from competent machinery, it's going south. Noise is increasing in the brain, and learning modulation and control is deteriorating. And you can actually look down on the brain of such an individual and witness a change in the time constants and space constants with which, for example, the brain is representing language again. So just as the brain came out of chaos at the beginning, it's going back into chaos in the end. And this results in declines in memory, in cognition, and in posture, mobility, agility. And turns out you can train the brain of such an individual, this is a small population of such individuals, train equally intensively for about 30 hours. These are 80 to 90-year-olds. And what you see is substantial improvements of their immediate memory, of their ability to remember things after a delay, of their ability to control their attention, their language abilities, their visual spatial abilities. The overall neuropsychological index of trained individuals in this population is about 2 standard deviations. That means if you sit on the left side of the distribution, and I'm looking at your neuropsychological abilities, the average person is moved to the middle or the right side of the distribution. It means most people that are at risk for senility, more or less immediately, are now in a protected position. My issues are to try to get to rescuing older citizens more completely and in larger numbers, because I think this can be done in this arena on a vast scale. And the same for kids. My main interest is in how to elaborate this to science to address other maladies. And I'm specifically interested in things like autism and cerebral palsy, these great childhood catastrophes, and in older age conditions like Parkinsonism and other acquired impairments like schizophrenia. Your issues, as it relates to the science, is how to maintain your own high-functioning learning machine. And of course, a well-ordered life in which learning is a continuous part of it is key. But also in your future is brain aerobics. You can get ready for it. It's going to be a part of every life, not too far in the future, just like physical exercise is a part of every well-organized life in the contemporary period. And the other way that you'll ultimately come to consider this literature and the sciences is important to you is in the consideration of how to nurture yourself. Now that you know, now that science is telling us that you are in charge, that it's under your control, that your happiness, your well-being, your abilities, your capacities are capable of continuous modification, continuous improvement, and you're the responsible agent and party. Of course, a lot of people will ignore this advice. It'll be a long time before they really understand it. That's another issue and not my fault. Okay, thank you.